Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is length of longest V-shaped diagonal segment. In this problem, the input given is a two-dimensional integer matrix or an array. So basically, we are given a 2D array, and this array contains integers, and these integers will either be 0, 1 or 2. The size of this particular matrix is going to be rows multiplied by columns, where rows is the number of rows in this array and columns is the number of columns in this array. This is not given as an input, we have to calculate this. Now the output we need to give is the length of the longest V-shaped diagonal. We have to find a V-shaped diagonal in the given input, and we have to find that diagonal whose length is longest. That is, that particular V-shaped diagonal contains maximum number of elements. Now to solve this, we have to know about what is a V-shaped diagonal, right? And let us try to understand about this using an input. So let us say this is the input given to us, a two-dimensional matrix which contains either 2 or 1 or 0. The size of this particular input is, there are 1, 2, 3, 4, 5 number of rows, and 1, 2, 3, 4, 5 number of columns. Now let us try to understand about what is a V-shaped diagonal. Basically, the first condition is this diagonal segment should start at 1. That is, your V-shaped diagonal will start with a 1. It cannot start with a 2 or cannot start with a 0. It will always start with a 1. After you have got a 1, the sequence will be 2 0 2 0 2 0 dot dot dot. It means the moment you get a 1, the next elements will be in the sequence of first 2, then 0, then 2, then 0, then 2, then 0, and this will continue till you can continue and create the longest V-shaped diagonal segment. So these are the first two conditions. There is another condition which is, once you start creating your segment, basically you will start creating your segment when you will get a 1. Once you start creating it, it starts along a certain direction, a certain diagonal direction. Basically, when you have a two-dimensional data, you have diagonals, right? You can have a diagonal in the top left. This can be a top left diagonal, or top right. This can be the direction for a top right diagonal. Basically, this can be a diagonal, or you can say this is also a diagonal, right? When you say a diagonal, you move in a certain diagonal direction. Or you can have a bottom left diagonal, a diagonal going in the bottom left direction. Or you can have a bottom right diagonal, which is going in the bottom right direction. So basically, your segment will start at 1, then continue with 2 0 2 0 2 0, and it will continue and start along a certain diagonal direction. That is, you cannot have a segment where you will start with a 1, then you will go up, then left, then up. This is not a correct direction. You will have to go in a certain diagonal direction. For example, you can start at a 1, then you can go in a diagonal direction, and this is a 2. Basically, that is your segment, right? Starting at a 1, then 2 0 2 0, and it will continue. So you can start at a 1, then go in a diagonal direction to continue your segment to create a bigger segment. So that is the third condition, start along a certain diagonal direction. Now there is one more condition which can give us a longer length V-shaped diagonal, which is, we can make at most one direction change in clockwise direction. Basically, when we are starting at a 1 and we go along a diagonal, right? So the third condition says that you start along a certain diagonal and you continue there. You cannot change the direction, but then it gives you one option that you can make a direction change at most one time, but in a clockwise direction. For example, if you are starting at a 1, right? This is your start of the segment or the start of your V-shaped diagonal. You have a 1, then you go in a direction in top right diagonal direction. This is the 2. Now, once you get a 1, then you get a 2. Now you need a 0, right? This is your segment sequence. When you go in the same direction, because according to the condition number 3, you can go in the same direction. You will get a 1, then 2, right? So this is the invalid sequence. Up to this point, it was valid. Now the condition number 4 says that you can make a direction change at most one time in a clockwise direction. So I was going in this particular direction, in top right direction. If I make a clockwise change, basically this is the clockwise direction, right? So if I am pointing to top right, if I change in a clockwise direction, I will go in the bottom right. So what I can do is, I can say I will start here, then I will go in the top right. That's my diagonal direction. Now I have nowhere to go because I cannot continue my sequence here. I will do a direction change to increase my size. Starting from 1, going in the 2, then doing a direction change. When you are going in the top right, when you go in the clockwise direction, it will be bottom right. This is the direction change, right? Top right to bottom right. Or if you are going in the bottom right, if you do the direction change in clockwise direction, this will be bottom left. If you are going in the bottom left side, if you do a clockwise direction change, you will go in the top left. And if you are going in the top left side and you do a direction change in the clockwise direction, then this will be top right. So basically, the direction change will look something like this. When you are going in the top left corner, this one, a direction change will make you go in the top right, this one. When you are going in the top right direction or top right diagonal, this one, and you do a direction change, it will be this one, bottom right. Now you will go in the bottom right. If you are going in the bottom right direction, and you do a direction change, then you will go in the bottom left. And if you are going in the bottom left direction, basically this one, and you change the direction, then you will go in the top left. So make sure that you remember this particular table because we will need this to solve our problem. So these are the 4 conditions to create a V-shaped diagonal. Now we need to create the longest V-shaped diagonal. Basically, this is also a V-shaped diagonal where we have just one element because all the conditions are satisfied. The segment starts at 1. After 1, the sequence will be 2 0 2 0, but there are no elements after 1, so this condition is also true. We start along a certain direction. We have not moved in any direction, so this condition is true as of now. And we can make at most one direction change. We will not make a direction change. We can make a direction change. We will not make it. Still, this is a valid V-shaped diagonal. But the length of this V-shaped diagonal is just 1. We can create a bigger V-shaped diagonal. For example, I can choose this one, then go in the right, top right direction. That's my first diagonal direction. Now I cannot continue, so I will move in the bottom left. Basically, I will make use of this particular power, changing the direction at most one time. So my sequence will look something like this. It will have 1, then 2, then 0. 1, 2, 0, and the size of this V-shaped diagonal is 3. Now that is a valid V-shaped diagonal, but is this the final answer? No, it is not. We have other ones as well. We have 1, 2, 3, 4. 4 number of ones, right? So there are 4 different points at which we can start and we can create V-shaped diagonal segment. Now let us try with each of the point one by one. So when we are trying with this particular one, basically our segment will definitely start with a 1, right? So we cannot try with other points because they are 2. We cannot start creating our segments with other points. But we can start at this particular point, right? Now with this particular point, we can go in 4 different directions. Either top right or bottom left or top left. Now bottom left and top left are out of our range, right? This is out of the 2D matrix. So we are not going in those directions. But we can go in the top right or bottom right. But the thing is, the moment I get a 1, my sequence will be 1, 2, 0, 2, 0, 2, 0, right? We need a 2. But we got a 0 and we got a 0. So the maximum length sequence will be 1, right? Now let us try with this particular data. We can go in the 1, 2, 3, 4. 4 different directions, right? But the thing is, if you go in the top left or bottom left, basically this particular direction and this particular direction, you are getting a 0. After 1, we need a 2, right? But we can go in the top right or bottom right. We can go in this direction as well, right? We already know that this is one of the V-shaped diagonal having the length of 3. Let us try with the other side as well, which is bottom right. I can start here and then I can continue in the bottom right direction, but the problem is when I continue here I get a 2. I have a 1, then a 2 and then a 2. I need 1, then 2, then 0, right? So this is not valid. But I can make a direction change, right? This is the 4th condition. I can change a direction. So what I can do is I can start here, then I can go to the 2, which is basically moving in the bottom right direction. But I know that if I move in the bottom right direction and do a direction change, I can go to the bottom left. So basically I am starting at 1, going at 2. Now I cannot continue. So I will start in the bottom left. I can continue, right? This is a 0 and I cannot go in the bottom left now because it is out of the 2D matrix. So this is one of the other V-shaped diagonal segment, right? The length is 1, 2, 3. So with this element we got a length of 1. With this element we got a length of 3. Let's try with this as well. With this particular element I can go in the 4 different directions, right? Now the thing is I cannot go in the top right because it is a 0. After 1 we need a 2, right? But after this 1 we have a 2 in all the other 3 directions, in all the other 3 diagonal directions. Let us try to process all the 3 diagonal directions. When I go in the top left, it is a 1, then we got a 2, then we got a 2. So we cannot move ahead, right? So up to this point we have this particular direction. This is our V-shaped diagonal, 1 and 2. Now we need a 0 and now we can change a direction. From top left we can actually go to top right. That can be the direction change in clockwise direction. If you go in the top right, still it is a 2, right? So when you start at 1, go to top left, the maximum you can go is a data of 2 or a V-shaped diagonal of 2 elements, 1 and 2. We already have a better answer, right? We have this particular V-shaped diagonal which have a length of 3. This particular has a length of 3 as well. We need to return the length, right? So we have a better answer which is 3. Starting from here, we are done with this direction and this direction. Let's try at this direction which is bottom right. Now you cannot continue any further, but you can do a direction change. But we cannot do the direction change because we have a 1, then a 2. Now we need a 0, right? This is our sequence. So we got a 1, then a 2. We cannot proceed ahead, but we do a direction change. And this element is also a 2. So we cannot proceed ahead. And this is one of the diagonal, right? It has the length of 1 and 2. The length is 2. Still we have a better answer which is 3. Now let us try from here in the bottom left direction. We got a 2. Now we can continue. We got a 0. So as of now, we have got 1, 2 and 3 elements. Now we cannot go in the bottom left because that is out of our matrix. But we can do a direction change. The direction change from bottom left will be top left. So we can go in this direction. But the problem is this is a 1. We started with 1, then 2, then 0. Now we need a 2. So we cannot actually move in this direction. And this is our sequence having 1, 2, 3. 3 elements. So again our answer is 3 at max. Let us try with the last one which is this. With this particular one, we can go in 1, 2, 3, 4 directions. These are invalid directions. And we cannot move in the bottom left as well because it is a 0. We need a 2. With a 1, I can go in the bottom right. it is a 2, I can go in the bottom right, it is a 0. Now I cannot go in the bottom right, but I can take a turn. If I am going in the bottom right and I take a turn, I will go in the bottom left. So my elements are going to be 1, then 2, then 0. Now I need a 2. I take a turn, I got a 2. Now I need a 0. Now I need a 2, but I don't have a valid element here. So this is another V-shaped diagonal we have. And actually this is our answer. We are starting from 1, then 2, then 0, then 2, then 0. Length is 1, 2, 3, 4, 5. And 5 is going to be the answer for this particular problem. Now we know how to solve it manually. But how we can solve it using programming? Let us try to understand this. See, the thing is, let us try to understand it one by one with each of the points we have, that how to find all the V-shaped diagonal, and out of all the V-shaped diagonal, we have to return the length of that diagonal which has the longest length or the maximum number of elements. Alright, so first of all what we can do is, we can simply traverse our matrix one row at a time, and for each of the element, for 2, 2, 1, 2, 2, 2, 0, 2, for each of the element, we are first going to check one condition, that the element should be a 1, because our segment starts at 1. So we are going to process each element, and then we are going to check if the element is a 1 or a 1, 1 or a 1. If it is a 1, we are going to proceed ahead with that element to find our V-shaped diagonal. If it is a 2 or a 0, we are going to ignore it, because our segment will start at a 1. Try to think about this. How are we solving it manually? To solve it manually, we are proceeding with each element in all the 4 directions, right? So simple, we have to proceed in all the 4 directions, right? Whenever we are at any element, we can go in the top right, top left, bottom left, right? Now let me tell you a very simple thing which you need to understand. See, the thing is, whenever we are at any particular element, right, this is the element. What do you know about this particular data? It is a 1. Apart from this, we know that it is in the row number 2, column number 2. I am talking about the indexes. We have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. These are the row indexes and these are the column indexes, right? This particular element belongs to row number 2, column number 2. Let me write this. We have an element 1 at row number 2, column number 2. Now when I say that with this element we can proceed in 1, 2, 3, 4 directions, what do we mean? We are basically changing the indexes of our current element. This is my current element. Now I want to point to this particular element. So I have to point to the row number 1, column number 3. This is row 1, column 3. So if I have to go from this particular data to this particular data, I have to change my row indexes and column indexes. Currently it is 2, 2, right? If I want to go in the top right corner, I have to go one row above. My row is going to decrease by 1. My column is going to increase by 1. My column was 2. I was at this particular point. Now I want to go to this particular point. The column is 3. Row is decreasing by 1 and column is increasing by 1. So what I can understand from here is, when you want to go in the top right corner, you have to go one row above and one column ahead. Row will decrease by 1. Column will increase by 1. And similarly, we have to write the same data for top left, bottom left and bottom right. Let's try to find out. Let us say we are at this particular point. The row index is 2, column index is 2. Going in the top right is -1 row plus 1 column. Going in the top left means you are going one row above and one column behind. It means -1 row, -1 column. So this will be -1, -1 from your current index. Now when we are at 2, 2 and we want to go to the bottom left, it means we want to go one column behind and one row ahead. When we are moving downwards, it means row is going to increase. When we are moving in the left side, it means column is going to decrease. So row will be +1 and column will be -1. And when we are going in the bottom right direction, it means if we are at 2, 2, we have to go to 3, 3. Row will increase because we are going in the downward direction. Column will increase because we are going in the right direction. So this will be 1, 1. This is the change we have to do to our current row and column indexes, basically 2 and 2, to go in a certain direction. So this is the first point which you need to understand. When we are going in a certain direction, we have to just change the row and column indexes. Make sure that you remember this particular point. Now, the next thing is, whenever we are doing a change, we have to be sure that, let us say we are at this particular one. We can go in 4 different directions. When we are going in this particular direction, which is out of our matrix, we are not going to proceed ahead, right? So we have to do that conditional check. When we are starting at 1, we need a 2, right, to proceed ahead, to create a bigger segment or to create a bigger V-shaped diagonal. It means whenever we start with a 1, we need a 2 to proceed. With 2, we need a 0. Then with 0, we need a 2 as the next element. Then we need a 0. Then we need a 2, right? It means we have to go to a certain element with a certain value. We should know that what is my next value, right? So now we are trying to relate something. Let's do one thing. Let's create a function to do this search. We are going to create a function search, which is going to get triggered whenever our element is a 1. Whenever we get a 1, we are going to go in the 4 directions to search for the biggest V-shaped diagonal. Now this search function will get triggered whenever we are at a 1, right? With a 1, we are going in 4 different directions. So this search function will take 2 arguments, the new indexes at which we want to start with. right now we are at 2 comma 2. We want to go in a certain direction, so we want to be at a particular index, right? So we need to pass the new indexes in the search function. So simply what we can do is this search function will take the new indexes, the new row, the new column. That is, if we are at 2 comma 2 and we go to the top right, then the new row will be 1 and column will be 3, right? So these are the two arguments it will take, and then it will take what is the next data we are searching for. Now let us say we are at this particular point and now we need a 2, right? So we are going to search with the next data as 2. The moment we reach a 2, this search function will try to go in this particular direction to create the biggest V-shaped diagonal, and also it will try to make a turn to create a bigger V-shaped diagonal. So it needs the current direction in which we are moving, right? At this point, if we are moving in the top right direction, we are basically saying that decrease the row by 1, increase the column by 1. This should be our direction at each point, right? Or I can say the direction can be top right. I can just pass this particular text and I can check it that if the direction is top right, then I will move in the top right. Basically, I will decrease my row by 1, increase my column by 1, right? And my next data search will depend upon the current value. If we are at 2, then we need to search for 0, then 2, then 0, then 2, right? Apart from all these 4 data, we also need to pass another argument, which is turn. The thing is, we have to make at most one turn, right? So we have to make sure that when we turn just one time. Now the thing is, guys, this is a pure case of dynamic programming. Reason being, whenever we are at a particular point, we need to go to 4 different directions, right? Now there might be a condition that with this particular one, we have searched for this answer, right? We have searched for this answer where we are moving from 1, then 2, then 0, right? And let us say there is a 1, then this is a 2, and there is a 0. And then we are moving in a certain direction, and now we take a turn, right? We already know that from 1, if we take a direction at this particular 2 and take a turn, the maximum answer can be 1, 2, right? These are the 2 more elements we can get. Similarly, if this is a 1, then we have a 2, then we have a 0, and we keep moving in this particular direction and make a turn, then we don't need to proceed ahead to find our answer, because we already know that if we make a turn and we are at 2, then the maximum answer we can get is 2, 0. So we are definitely going to utilize the answer of different results we are getting, right? So this is a pure case of dynamic programming where we are going to divide our problem into a sub-problems and we are going to utilize the answers of those sub-problems. Now let me take you back to the code editor and let me try to explain you the code, because whatever we have discussed as of now, that is going to be our code, and the code is very clean. So let me take you back to the code editor and try to explain you that. Alright, so first of all, we are going to create 2 variables, rows and columns. Basically, rows will be the number of rows and columns will be the number of columns. Then we are going to create a function search. I will tell you how this function will work, but before this, let us focus on this part of the code. We are creating a result variable where we are going to store the maximum length of a V-shaped diagonal. Now we done a simple loop for r in the range of rows and for c in the range of columns to traverse into our matrix and check that if the current value of our grid is 1, then we are going in the 4 different directions. And now you will see what we are doing. We are trying to find out the maximum of the current value of result, and we are doing a search. Now we are searching in 4 different directions. We are going in -1 and -1. Basically, this is going to be top left corner. From our current r and c, we are going in r-1 and c-1 direction. So basically, this is the top left, and we are saying that the next element we need is a 2. And this is a false. It means we have not made a turn as of now. Basically, if you see our search function, it is going to accept the current r and c, basically the current row and current column index. Then what is our next target? And then have we taken a turn as of now or not? And then the current direction. So we are making a search in top left direction, top right direction, bottom left direction, bottom right direction. And when we are making a search, we are saying search +1. This +1 is because we got a 1, right? That 1 is also going to contribute into our longest V-shaped diagonal length. And now let us focus on the search function. And before we go into the search function, you have to see this cache. What this cache is doing is, it is actually going to store the data which this search function is going to return. So basically, when you are calling this search function with a certain set of r, c, target, turn and direction value, if it is already having that data in the cache, we are not going to do the processing, we are directly going to get the result. This is for the dynamic programming memoization logic. This is the memory for our dynamic programming. This is going to avoid doing the same processing again. Now let us see the search function. It is actually easy to understand. It is a long code. You can find the code in the pinned comment of this video. It is a long code, but it is very easy to understand. First of all, there is a simple check that if the current value of r and c, if that is out of the range of our matrix, if r is less than 0, or c is less than 0, or c is more than equal to the number of columns, or r is more than equal to the number of columns, then we need to return 0. It means we cannot proceed ahead and return 0. There is another condition check that if at the current data in our matrix, if the grid of r, c is not equal to target, it means although we can proceed, but we do not have our target, we cannot create our sequence, then also we return 0. Now, if this condition is false, so we can proceed ahead to create a bigger length diagonal, right? Now, definitely we are going to return the result with +1 because we got a data, but now our target will be equal to 0. If the target is 2, otherwise it will be 2. That is, if the target is 2, now the next target will be 0. If the target is 0, the next target is going to be 2. And as of now, the total data we have got is 0. We are going to increase the value. Now, there are two more conditions. This if turn, else. Now, this if turn is telling me that have we taken a turn or not? Because we can take a maximum of 1 turn, right? So if we have already taken a turn, should be our logic. If we have not taken a turn, this should be our logic. And let me explain you what it is. Let us say we have not taken a turn. So we are going to go in the else condition because we are sending false here. Initially we are sending false, right? Now, if the direction is top left, so we have two different things to do. Either we can continue in the top left direction or we can actually take a turn, right? So we are saying that the total will be equal to the maximum value of current total. And let us do another search. Let us do a recursive function call. And if we want to continue in the top left direction, we have to say r-1, c-1. And then we send our new target. And this will be false. It means we have not taken a turn. We started with top left. We continued at top left, right? And this will be +1. It is telling me that I have got one data and let's continue to find more data for our V-shaped diagonal sequence. There is another function call of search function, but in this time we are actually changing the direction to top right. From top left we can go to top right when we do the direction change. From top right we can go to the bottom right. From bottom left we can go to top left, and from bottom right we can go to bottom left. But this time we are sending the value as true. That is, we have already taken a turn. The moment we call our search function with a direction change, we are going to make the turn as true because next time we cannot take a turn. So here we are trying with all the 4 directions, and we are trying with moving in the same direction, and we are trying with a turn as well. Every time we are saying that the total will be the maximum value of current value of total or this particular data, whatever you get here. And at the last we are returning the total. And there is one more condition, that if turn is true, in this case what we are doing is, if we are moving in the top left, we will move in the top left. Moving in top right, move in the top right. Moving in bottom left, move in the bottom left. And moving in the bottom right, we will move in the bottom right. And every time the turn will be true. So I think the code is very clear to understand, guys. We are basically doing everything what we do manually, right? And we are doing it just with the function. So this is the complete code for this particular problem. At the last we are returning the total from our search function, and after we have calculated the search in all the 4 directions, we are going to return the maximum value of result. And if you submit this is going to pass all the test cases, and you can see that the runtime is really good, the memory used is really good as well. The time complexity of this problem is going to be rows multiplied by columns, and the space complexity is also going to be rows multiplied by columns because we are storing some space using this cache, right? So guys, I think we have solved this particular problem, and that's it for this video. If you got to know something from this video, if this video helps you to understand something, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.